I am so excited to introduce you all to Chris McWhinney, the CEO and founder of Millennium Reign Energy. Chris, welcome to the High Sky Pod.
Thank you, Danielle. It's a pleasure to be here.
Likewise, I was so excited to learn about your company. I think it was the end of last year, it was about the end of 2024 ish. Some of your colleagues told me about you. I had been saying, like, we need some infrastructure folks in hydrogen aviation. We need somebody producing hydrogen. And then lo and behold, there's this company in Ohio that pretty much has the holy grail of what I felt for a long time is missing from hydrogen aviation. So tell us a little bit about what Millennium Reign Energy does.
Sure. Well, there's basically five things that you need to build hydrogen fueling infrastructure. You have to make the hydrogen, you have to purify it to fuel cell grade, you have to compress it to either 400 or 700 bar or 500 even. You have to be able to store it at those pressure levels, and you have to be able to dispense it safely into a vehicle of some type. In this case, we're talking um, eVTOLs or drones or some type of advanced air mobility platform. So we are able to do all five of those things at one place. Whereas much of the industry is made up of a company that does one or two of those things, we put it, and then they have to be an integrator of somebody else's product to what they do to make the whole thing work. We put together a platform and a manufacturing facility that can do everything in one place. And we even include the water purification system. If you wanted to say there's a sixth thing that goes into making the hydrogen to begin with. And so we have multiple products that we've developed over time that we have spent the extra money and time to ensure that they meet the proper codes and standards in the United States. And we have certificates of attestation from CSA Group, which is a internationally recognized third party um, laboratory, testing laboratory. And they took a look at our systems over a period of 18 months and then 11 days in a row in our shop doing rigorous testing and analysis, and much time spent in developing the standard to begin with, which is called IR 3-18, and for the hydrogen fueling appliances, and IR 4-14 for the electrolyzers, which will soon become a code called B is going to replace that. So we have spent a lot of money and a lot of time to make sure that these products not only do everything that somebody needs, but they do it safely. And finally, in the process of learning how to do that, we figured out how to make them so that they would be considered an appliance. And then, therefore, because they're an appliance, they don't have to have a permit to be able to be put in place. And so that doesn't mean you can just run right out and put one anywhere you want, and because it doesn't need a permit, because that's going to get the ire of the authorities having jurisdiction, because they don't know that. No one knows that. So you take the documentation that comes with it, you take it to the authority having jurisdiction in that county or city or whatever, and you say, hey, this has been done so that it doesn't need to have a permit. And every time we've done that, they say, yep, you're right. It's an appliance. You don't need a permit. So now we have their blessing, and they know when they see another one pop up, we've already been there, done that, and it doesn't create a problem. So that was a big deal because that slows things down a lot in the industry when you're building hydrogen infrastructure.
It's so incredible. I still am mind blown that it's actually an appliance. It's really hard for me not to picture a refrigerator when I think of that. But that's very cool that you have the insight to do that. And so walk me through a little bit about, and by the way, guys, I've been out here to Millennium Reign Energy. I had a blast. I was so impressed by the team and what they're building. And Millennium Reign Energy is the real deal. And Chris, I told you this when I was out there. I it's written. I picture your face will be on the cover of Forbes because you've been so early on in this space and your systems are so affordable. So, like, I remember hearing about the ones in California, the refueling stations. They're like 10 million a piece to build, and they don't even produce their own hydrogen. Your system does all of that for less than a half a million, around a quarter of a million. When did you start on this? Talk to me about when you had your flux capacitor moment.
Well, so I started in my garage in 2003 trying to develop the electrolyzer portion of the system. My partner, Dave Erball, who's still with me today, he was the genius with the knowledge, the foreknowledge of hydrogen and electrolyzer, how an electrolyzer worked. As a matter of fact, I was a financial advisor and a farmer before this part of my career, and I never went to college. And so I had no way of understanding what an electrolyzer was. And I was training him to be a financial advisor, and afterwards went to his house to discuss the appointment that we were just on with a potential client. And I saw this weird thing sitting on his desk, and I was like, "What is that, Dave?" He goes, "It's an electrolyzer." And I said, "What's an electrolyzer?" He said, "Well, it makes hydrogen and oxygen out of water and electricity." I'm like, "Really? Well, what good's the hydrogen?" He goes, "Well, the space shuttle runs on it." I'm like, "You're kidding me. We can make that kind of fuel out of water and electricity. Why aren't we doing that today instead of gasoline?" And his comeback was that this was really early on. This was like 2000, I mean, 1999-ish, something like that. And his comeback was, well, it takes a lot of electricity to run the electrolyzer, and that's expensive. And then the equipment itself is really expensive. And so those two arguments gave me my starting point on how do I solve those two issues. Being in financial services, I understood money well enough to understand that if you can amortize the electricity over time, then you could lower the cost of the electricity. So how do you amortize electricity? You do that by buying wind and solar, and you spread the cost of the installation of the wind and solar over time because the electricity, once it's erected, is free.
Mhm.
So that's what gave me the idea to use wind and solar, not so much because it was green, but because I was trying to make my electricity costs drop. And but then learning about more and more, the green aspect of it became very important. And then the other part was just a blessing of ignorance on my part, that I was ignorant as to what things should cost. And being a farmer, I used to look at a 4020 John Deere tractor, and a diesel tractor, and I would look at it and I know what my dad paid for it. And I was like, I don't understand why that thing costs so much. It's just a hunk of metal molded into, something useful, and I don't really understand why it costs so much. And that was the blissful ignorance that I possessed, to not understand the manufacturing techniques and principles that were involved in trying to build something. So that led me to believe that I could possibly build something less expensive. And then when I started looking at the electrolyzers and how they were constructed at the time, there was two basic types: alkaline or proton exchange membrane. And proton exchange membrane um, is something that's made with precious metals and rare earth metals that you hear about
Mhm.
all the time. And, so these cost a lot of money, like platinum. Platinum oftentimes is more expensive than gold. So if you said you were going to build a gold electrolyzer, it's a no brainer. It's going to be really expensive, and platinum is a lot of times more expensive than that. So they adhere platinum to a substrate in some cases, like Nafion. Nafion is the same thing that they use for bulletproof material, for bulletproof vests, layers and layers and layers of it. And so that's a really expensive substrate. So when you combine those together, you could be as high as between 400 and $600 a square yard to build your substrate. And with alkaline electrolyzers, we figured out how to use a product that we patented, that could only cost $6 a square yard. So, and then we use readily made available materials like plastics and stainless steel blends to make the rest of the electrolyzer. So there's just no way that you can make an electrolyzer any less expensive than what we make it. And so lowering the cost of the capital acquisition cost of the products, because I was a financial advisor, was really important, because it doesn't matter how great hydrogen sounds if the end user can't actually write a check and make money from buying your product. You're not going to sell very many of them. And so
Exactly.
that's that's
Can I
that's
ask
what.
you a question? Can
Yeah.
I ask you a quick so sorry to jump in, but I didn't want to get too far away from this point because I was an aerospace engineer that isn't a chemical engineer. I mean, I also have a mechanical engineering background, but it was still light on the chemical side of things. I understand what alkaline means from like a pH level standpoint. And I feel like fuel cells, electrolyzers, and the stack as well. Well, I guess they're both the stack, right? You have your electrolyzer and then you have your hydrogen fuel cell, which, as I understand it, kind of is reversing the process, like what goes on board. But in your hydrogen production phase, we're talking about for the listeners and for me as well. We're just talking about production here. Why do people pursue the proton exchange membrane when you need that rare earth metal? Why is it sort of, I guess, from my ignorant perspective, because I'm very new to hydrogen production, why is it sort of promoted as something better? And why isn't everybody doing alkaline? Is it because they didn't have your patented product? Could you explain that? I don't understand that part of it. I'm very ignorant to that.
That's a very good question, and there are very many people that understand that answer to that question, but it's better to start with why did they develop proton exchange membrane to begin with? Because alkaline was the original type of electrolyzer. Back when the Germans were electrolyzing hydrogen to make hydrogen to create the hydrogen that they put in the Hindenburg, those were alkaline electrolyzers. Norsk Hydro, one of the oldest electrolyzer companies around. Those are
Mm,
alkaline electrolyzers. And so why did they go the other way? Because it was thought and it was proven that if you would put a catalyst on your membrane, that you could use less electricity
I
to
see.
create the hydrogen. And the key factor in producing hydrogen cost effectively is not so much the capital acquisition costs, like everybody talks, oh, we got to get the cost of electrolyzers down. No, it is the cost of electricity. It is the single biggest factor when you put the calculations together. That is what costs so much to make hydrogen. So if you can use less electricity, then you're going to be able to get the cost of the hydrogen down. And that's what drove proton exchange membrane. And for years, it was a fact that the proton exchange membrane was more efficient at using electricity to turn water into hydrogen and oxygen than an alkaline electrolyzer was. Also, they can produce a lot of pressure. This is less work for your compressor to do if you can give your compressor higher input pressure to begin with. So
See.
what we discovered, and as part of our patents, is we discovered a way to develop an electrode assembly that gets the bipolar plates close enough together that the losses that are typically come with an alkaline electrolyzer go away. And in a lot of cases, we have better efficiency with alkaline now with the way ours is designed than they do with proton exchange membrane. So this is
Wow.
a real breakthrough, and it's one of the causes of our patent. So, like,
And you don't
I'm
have
gonna
any
grab
rare earth metals either,
I'm
right?
yeah, I'm gonna grab something here and show you real quick.
I love it.
Just dawned on me that I have this available and I could show this to you. That this is one of our I made this as a trophy to give to our early investors, so that's why it has this placard on the front, but it's actually a functioning alkaline electrolyzer. So
Nice.
on both sides here, you have two electrodes. You have an anode and a cathode, and this over here is the negative input, and this one is the positive input. So because this one's negative, hydrogen is going to come up this column, and oxygen is going to come up this column. And the separation between the two is this big plastic piece on the back. There's like 2.5 inches of plastic between these two electrodes. So if you run this for a really long time, it'll get hot because the distance between the electrodes is creating heat. So you're losing a lot of your electricity making heat
Mhm.
instead of making hydrogen and oxygen. So the key is how close can you get those electrodes together? And we created a what we call a chamber plate that nestles the bipolar plates, which is what's between the anode and the cathode, to close enough together that you could get water in the cell as fast as gas is coming out of the cell.
Mm.
Because if you get it too close together, you can't get water in the cell because the viscosity of the water doesn't want to flow up in there fast enough to replace the bubbles as they're coming out. And if you
Mhm.
get it too close together, also it'll short out. So you have to keep your bipolar plates and your anode and cathode separate from each other. But if you get them too far apart, now you're starting to lose efficiency and heat. So we found that optimal gap in order to make that work. And that's also part of our patent and how we make the electrolysis work more efficiently on alkaline than we do with proton exchange membrane.
Got it. And you all manufacture those in-house. I've seen them being made. Thank you for that explanation. I think I finally got it. And I would venture to say that the if we're looking at the entire process, the proton exchange membrane is only more efficient and cost effective if you're looking at the acquisition of the rare earth minerals and the cost of electricity, all of that together. If you're
Yeah,
looking at all of that, then alkaline would win, would it not?
we think so. And
I think so too.
we've done a tremendous amount of work with spreadsheets that can prove it with, not only math, but money math. And
And looking at your, you have how many units do you have? How many countries are you guys in? Because this is not just theoretical. I mean, you're talking about spreadsheets, but you guys have actually sold these units. They're in operation. How many countries are your stations in?
well, over the time, we've had 37 units in operation around the world in 8 different countries and 7 or 8 different states. And so we have a lot of time of running these. Our very first installation outside of working one at our place, we put in Texas in 2008. And so we've been continuing to develop that relationship of understanding how to continually improve. One of the deals that we make with every customer is it's not like, it's like a lot of people's like, yeah, we made a sale, yeah, sure, we'll sell you this. And we're like, we'll sell you this if you promise that you're going to be more of a partner than a customer, because we're not so sure about how all this works when it goes out in the field and you use it versus us using it. So the feedback that you can provide us on, hey, it did this at this time and I didn't think it should, or hey, I screwed up here and I'd opened this valve at the wrong time and I did this, it flooded this. And we need you to be honest. We're not looking to burn you or kill your warranty because you screwed it up. We really need you to understand that you can help us
Mm.
by telling us the truth about the way you operate it and the way it functions. And we've been so blessed to have customers do that, that became partners instead of customers. And that is what has attributed to us being able to get to where we're at today, is that relationship between our partners.
It's so incredible, and I've seen it, I've seen this firsthand. I've met some of your customers, met some of them in person, some on Zoom, and it's just been really cool to see how you run a business. It's very unique. Some things, are standard, but then you have things that are unique, and you really do care about what you're doing. And I just think aviation and aerospace is so lucky to have somebody like you getting into this space because we hear these astronomical numbers for how much it costs to produce hydrogen, and people they want to start so big. And I think this is one of the things that has hurt hydrogen, because it's sort of this all or nothing kind of thing. But we do need to start small, and that's exactly what you've done. And you
Mhm.
guys are at the point now where you can start to scale, so you proved that the technology works. Let's talk a little bit about what could it let's say, an aircraft is, going to use hydrogen versus batteries, or because, for some of our listeners, you mentioned eVTOL and advanced air mobility earlier. Let's talk about, like, say, a helicopter or a drone that was powered by hydrogen, that had hydrogen fuel cells and was using your refueling station, using your station to get their hydrogen. Let's talk about what, kinds of missions they might be able to do versus if they, were just powered by batteries. What are you seeing?
So, the first example that I would give was that 3 years in a row, we were able to demonstrate one of our Model 200s at the Rempus um, uh, uh, NATO conference in Portugal. And there's a NATO base there that is also duplicates as a Navy base for the Portuguese Navy. So we were able to set up our Model 200 there, and we fueled a drone, and it flew for 4 hours on gaseous hydrogen. And the day before, that same exact airframe and drone had a battery pack in it. And it flew for 45 minutes on batteries before it had to land to be recharged. And then it took them 6 hours to recharge that battery pack. And when it landed with hydrogen within 30 seconds, the tank was refilled and ready to fly again. So there are huge advantages to hydrogen, even gaseous hydrogen over batteries, which we recommend for a lot of people. It's simpler to start out with that, get your feet wet with hydrogen and fuel cells and the electronics and everything that runs, and then jump to liquid because the liquid is going to give you an even further range. There are some companies recently that have flown full-size manned eVTOLs that went for 9 hours without having to be refueled on liquid hydrogen. So the range aspect is a big one. Flight time in the air is a big one. Refueling time is a big one. And then weight savings is a big one because the fuel cell itself weighs hardly anything compared to the batteries. And then you have to add a fueling tank. And there are type 4 fueling vessels that you can get that weigh very little, also respectively to batteries. So there are four really obvious reasons why if you have an advanced air mobility platform, you should really seriously consider hydrogen as soon as possible into your platform because it's going to give you and your customers a huge competitive advantage to run on hydrogen.
I couldn't agree more. That's so cool. And if we talk about like life-saving missions, see that flights that save lives. We talk about like emergency helicopter, medevac, organ delivery. Those flights tend to be 300 miles average or more. And if we're seeing, fossil fuels, maybe there's not secure way to get them or they're becoming more expensive, less available, batteries aren't going to cut it. So people are going to have to use hydrogen.
That's right.
And, you guys are in the perfect space. Also, it's interesting that automotive, everything's going to move towards hydrogen. Everything is going to move towards hydrogen. Hydrogen is an energy carrier. And if people are invested in this now and involved now, they could be, the Elon Musk of of hydrogen because batteries won't cut it. Eventually, we're going to see automotive and maritime and aviation and
Mhm.
buses and all of this going to hydrogen. And you all have the secret ingredient that's missing from it. You mentioned something earlier that I want to talk about. You mentioned that it all comes down to your cost of electricity. A lot of people in this space, not so much on the energy side of it, but I would just say from my perspective, from my point of view, I see a lot of people that talk about building hydrogen refueling stations, but they consider maybe making their own hydrogen, but a lot of times they're, bringing it in from somewhere else. And so we always say the closer you can have that production to where you're dispensing it, the cheaper it will be, right? You're
Right.
taking it a step further and saying, make it yourself. You can verticalize the entire supply chain of your fuel.
Right.
And then it all comes down to your price of electricity.
That's
And
right.
so, many of us that are in this space, we know that the hydrogen should be green if you really want to have those benefits to the environment. And when I met you, you said you guys were using green hydrogen, but you're in the middle of Dayton, Ohio. And I'm like, how the heck are you guys? Because in my mind, I thought green hydrogen meant we need to be, I wrote a white paper. I co-authored a white paper that had all of these solar, farms and this and that. So how are you in the middle of downtown Dayton, Ohio, making green hydrogen? Imagine somebody's never heard of a PPA before and talk to us a little bit about that because that's where I think the biggest opportunity is in this space.
Yeah, so the way we do it is if I slide my camera to the right a little bit, you can see that paper hanging on the wall over there next to our ed unit. That paper's from American Electric Power, and it says that we're buying electrons that were produced by a wind farm north of here. And so we don't have to have the wind farm on site to be buying green electrons. So through a power purchase agreement, if you have the opportunity, you can check that out and sign your electric usage up through a power purchase agreement. and then you can get green electrons without building that. So that solves half of the problem. You now have green hydrogen, which is highly sought after and much favored as opposed to brown hydrogen or blue hydrogen or all these other different colors. So, which are basically the color codes are based on where your electrons originate from. So the other piece of the puzzle is, and the biggest piece is the cost. And so this is where you were talking about being vertically integrated is we believe that when you're going to do hydrogen at scale, that you shouldn't be looking at how much does the hydrogen cost and where am I going to hook it up to a wind or a solar farm. You need to be looking at, I'm buying the whole package. I'm going to finance and I'm going to create an entire financial structure from top to bottom that includes building the wind and solar farm and the hydrogen production plant all in one place at one time. Now, the reason that you do that is because anybody that would research and find out what does it cost to build megawatt class utility scale wind these days, wind
Mhm.
farms, you're going to find out that it's less than 2 cents kilowatt hour. So, and our product has been measured at 48 kilowatt hours per kilogram to make a kilogram of hydrogen. So, if you were to get your electric cost at 2 cents a kilowatt hour, and it takes 48 kilowatt hours to do that, simple calculation here is 48 kilowatt hours times 0.02 cents is 96 cents kilogram
Mhm.
for hydrogen. Now that's just your electric cost, operations and maintenance cost, and you have your capital acquisition cost. So you got to calculate those in. But by the time you get done at 2 cents, you can come in around $2.75 per kilogram for your cost, okay, of doing business.
Mm.
And so then there's another thing that most people don't know when they start to calculate whether hydrogen is something worthwhile investigating is, and I'm going to use cars for an example for this one. You have an internal combustion engine that everybody's trying to compare against, and the internal combustion engine, based on the Department of Transportation's figures, averages about 25, 26 miles to the gallon of gas equivalent, or miles to a gallon.
Mhm.
So there's this thing called a GGE in hydrogen. So it's how you make a comparison of your hydrogen usage in comparison to gasoline in an internal combustion engine. And so if I told you that I was selling you hydrogen for $12 a kilogram, but on the other hand, and you look at this is where the GGE comes in. It's based on the BTU equivalent of a gallon of gasoline has a very similar amount of BTUs in it as a kilogram of hydrogen. So that being the basis, and people are saying, okay, well then a gallon of gasoline is equal to a kilogram of hydrogen.
Mhm.
That's on energy content. But because you're using a fuel cell to turn that hydrogen back into electricity, the fuel cell will go 2.8 times further on a kilogram of hydrogen than the internal combustion engine car will go on the gallon of gasoline because you have all the friction in the crankshaft, the camshaft, the pistons, the transmission, and the rear end. All that friction adds up to using more energy, more of those BTUs to transfer that into motion. In an electric car, you have an electric motor that's getting an AC current from a fuel cell that started out as DC, and it's using a converter to get it to AC to drive the AC motors. The efficiency is so much better that you can go 2.8 times further on the same amount of BTUs. You can't just say, because if you stopped right there and you didn't do the rest of the math, a person would think, okay, well, $12 for a kilogram and I can buy gasoline for $3. Heck, it's going to be a long time before hydrogen becomes comparable with gasoline. But you got to do that 2.8. You got to divide that 12 by 2.8. So somewhere along there, when you get to like $10 and you divide by 2.8, you end up at $3 or below for a gallon of gas equivalent. And now all of a sudden, if you're making hydrogen at 2 cents a kilowatt hour, and because you're driving it with wind and it's green, now all of a sudden you can actually sell hydrogen for less than the cost of gasoline. So now there's a reason for everybody to go hydrogen instead of just trying to say it's green and it's environmentally better, which it is. but that's not gonna get the majority of the people to make a change. You've got to
Chris, I am so sorry to interrupt you because whoa, I was feeling that. We are getting a massive thunderstorm. And as you're talking, the thunder, it's like God is coming down. And I don't know if you could hear any of that, but I just
No, I
wanted to
can't.
tell you,
Can't.
okay,
Yeah.
if I cut off, we might have a power outage today and
You
see the
catch you
lightning.
catch you catch some of that electric, and we'll make some hydrogen out of it.
Yeah, so if the call abruptly ends, then that's
Okay.
why.
Okay.
I'll just I don't know what we'll do, but oh my gosh, it was so intense for my end. I really hope we have some of that. But I mean, what is it right now? What are you guys making hydrogen per kilogram right now?
Well, 10 cents is what I end up paying on my bill. It's only 5 cents for the wind,
I see.
electricity, but by the
Mhm.
time the energy company does this wheeling charges and
Mhm.
and then their operations and maintenance costs and everything, you end up at like 10 or 11 cents a
Mhm.
kilowatt hour. So at that rate, you come in at somewhere around $3.86 a gallon of gasoline equivalent. Um, and so which isn't bad because, like, in Hawaii and in Europe, the European Union and places like that, that's still cheaper than gasoline. In the Caribbean island nations that are having to import everything, they got extra cost involved in that. That will fly in those areas until
Mhm.
we get, so the key though is, and you said something earlier I want to reiterate on, is where in my opinion, my humble opinion, where everybody that's done this in a big way is making a mistake is they're looking at the way infrastructure is built now for gasoline, and they're trying to duplicate that for hydrogen, meaning you got 4 islands of dispensers and you got all this gigantic volume of gas, and that's why it costs $4 million in California to put up a station, is because you got all that stuff going on. Well, our approach is radically different in that we say, "Hey, you need to do this very important thing here and never forget these words: dynamically match supply with demand." You can't do that if you go in there and you put in a station that's supposed to handle 200 cars a day and there's only 10 cars in the neighborhood.
Mhm.
It's going to be forever before you're ever going to make enough money to pay that thing off.
Mhm.
And you're not going to get investors to back that program when they can't never see any light at the end of the tunnel for a return on investment. So what we're doing is we're going in there with a $250,000 station instead of a $4 million station that'll having 7 cars a week instead of 200 cars. And trying to match the amount of cars available with the amount of hydrogen available. And what we've done is we've built scalable hydrogen fueling appliances that are in 4 different scales: a model 200, 300, 400, and an M470. And these aren't something like we got to go figure out how to build next. They're already built, on the ground, running. So we already have the scalable ability to, as you grow your market, you take that station out, you put it over here, open up a new territory and bring in the bigger the one that handles more volume. And you can do that 4 times and keep moving these stations around like chess pieces. Okay. So it's strategic in the way you're doing it. And you're reusing a capital expenditure and moving it to a new location to open up more territory and more customers.
Mm.
So that increasing the demand for the hydrogen as you increase the supply of hydrogen in unison with each other. Now, this is something no one else that we're aware of, and I'd love to know it. So if you listen to this and you wanna confront me on this, have at it, okay? Because I wanna know if somebody out there's got something like this, but I don't think they do. And so this is because no one's ever conceived of products that could be designed like this. They never think of the idea, and they keep going out and building these gigantic stations without. And now we figured out how to do this on a truck stop level. We can do this on an eVTOL level. Any level we can scale with the demand. And one other thing I want to say that's really important about hydrogen versus batteries. You need batteries. You're never going to get away from batteries because the batteries are provide you a constant load, and you can increase that load really quickly and back down, and it's going to give
Mhm.
you that power when you need it. And you're never going to get away from them. We know, but they have a specific use. And
Yeah.
once you get beyond that specific use, hydrogen becomes a better deal. And so one of the things is that if you wanted to be green in batteries, you're going to have your vehicle sitting there at the moment in time when the wind's blowing or the sun's shining in order to capture those green electrons. But with hydrogen, you can set your hydrogen generation equipment, your fueling station, your electrolyzer up, and it can be making hydrogen anytime that wind or solar is present, and then fuel the vehicle at some later time. So you're transferring green electrons, and you can't do that with batteries.
Yeah,
So
you
big
just wanted
difference.
to I just wanted to add, we don't get this question so much anymore, but I used to get it a lot, especially about 2 years ago. People would say, "Do you don't you wanna use batteries or hydrogen?" And, our motto, High Sky Society, advancing hydrogen aviation, but we've added to it, High Sky Society, advancing hydrogen aviation, batteries included,
Mhm.
because, the folks that are using batteries know the benefits of electric, and the folks that have already went electric are seeing the limitations of batteries and are becoming interested, and we will always need a battery component. So it's not an either or, it's yes, all of it, all of the
Right.
technologies. You said so many interesting things. So is it Millennium Reign Energy's goal? Because, we're talking about the cost of electricity. Is it possible to get it down to 2 cents with doing a PPA, or would you need to have your own wind farm? And is that something that you all are looking at? What does that kind of look like? If say somebody was interested in going big with this, what would they need to consider to get the lowest price of the hydrogen possible?
I would say with a PPA, if you're going to use commercial rates and places in the country that allow commercial rates, you would be able to get down to 6 or 7 cents a kilowatt hour, which is still pretty good. And you can still beat gasoline and diesel fuel at that kind of price, but it's not like such a big savings anymore. It's not like on par with gasoline and diesel fuel. In order to get down to the 2 cents, you really have to create a project and fund the whole thing where you're building the wind farm, the solar farm, and the hydrogen as a package deal.
Mhm.
And that's how you get that low.
Now, let's say you had like a main headquarters in, I don't know, somewhere in Ohio in the country near Dayton. And you have this massive wind farm, or possibly just maybe it's in Hawaii. Okay. You have a massive solar and wind farm. You have something that's producing, maybe Hawaii is not a good example, but somewhere in the United States, you have a massive solar and wind farm. You're producing tons and tons of hydrogen, or let's just say you're producing tons and tons of electricity. Could you sell that electricity? Genuine question, I genuinely don't know. Could you, like, have a PPA with, like, yourself? Like, say you had another station in a different state, could you have a PPA with yourself, like, another station to sell the hydrogen or sell the electricity to, so that each one of your stations doesn't need to have their own solar and wind farm?
Yeah,
Or
so
okay,
what you
yeah.
would do in that instance is so I talked about how you have the stages. You have the Model 200, then the 300,
Mhm,
400, then the M470. Once you get those stations in a physical location and they're making the hydrogen, purifying it, compressing it, storing it, and dispensing it all on
mhm,
site, you run out of real estate and you can't get any bigger. At that point is when you build the wind farm hydrogen, we call it hydrogen harvesters, and
mhm,
then you truck that hydrogen that you're making with green energy at a lower cost to your existing fueling nozzle network that you've built through developing it with the scalable hydrogen fueling appliances. And so that would be the way that you would get your low cost hydrogen off site. Now, however, you did mention one other thing, is that you can develop that whole system as a microgrid. And if you add fuel cells to it or turbines that can run on hydrogen in addition to fuel cells, you could sell your excess electricity back to the grid and make another value proposition to make your entire hydrogen operation farm out better on a pro forma, because you now have your can sell your excess electricity until you get a demand for the full blown amount of hydrogen that you can distribute to your outlets. You can sell that back to the local grid,
mhm.
and
That's very
they will pay bonus to store energy that can be dispatchable upon demand to offset peak demands. We went through this with a partner of ours that had installed over a gigawatt worth of wind and a whole bunch of solar as well. And we created a 1 inch thick pro forma on how all this would work. And this is how I've learned these things. We did that clear back in 2016, and we've been developing ideas around that whole thing ever since.
It's all connected. It's so interesting. It reminds me of a company in Texas. So in Texas, I don't know if everybody has these grocery stores called HEB, but they're big here in Texas, especially in the Houston area.